All right, this is section 1.6, subtracting real numbers. Again, real numbers are everything. Everything. So this homework might appear just a little bit harder than what the notes do, because the notes are just reminding you of the process behind subtracting numbers and not throwing in fractions. But the homework might make you do a common denominator on it. Okay? So keep that in mind, that it might not exactly reflect. Okay? So there is something that I say in class, in this class, that some teachers don't say. If there are A and B and they are real numbers, then A minus B is the same as A plus negative B. Okay? What I say on this to change from one to the other, I put a line here and a line there, and when I do that, some people like it, some people hate it. I say chunka, chunka. Every time. Chunka, chunka. Okay? So if you want to write it out, chunka, chunka. And some people chose to change that up a little bit last year. If I'm doing different things, they said chunka dunka. I don't care what you say. I don't even care if you say it. But I say it as I'm doing it. Okay? So, in order to make this easier on us, because subtracting in negatives is hard, it messes with you. Okay? So instead, let's just change everything to a negative and make it a plus problem. Because last class was easy because we were adding everything. So if we're adding, it's super easy. So if I chunka chunka, now I can just combine my like terms, my like negatives. So common sign, 4 plus 13 is 17. Okay, this is the one where they said chunka chunka because it's the same thing. You're doing both vertical lines. So that was chunka dunka, this is chunka chunka. Okay, so chunka chunka. Now you got plus. See, some people, they just can't do it. So now you got two positives instead of minus a negative, which is annoying. Okay, you got two positives, so you can just combine and take the common sign. They're both positive, so it's a positive answer. Chunka dunka this time. Okay, subtract and take the bigger sign, right? Big minus little, take the sign of the big. Next one, chunka chunka. 7 minus 1 is 6, and the sign of the big is the big one. Yes. Yeah, I don't know why I wrote 6. Good catch. I don't know why I wrote 6. There you go. Good catch. Okay, so big minus little, and then take the sign of the big one. So yes, -3 is the correct answer for that. Okay? Oh, so I do have a little bit of fractions on here for you to make sure that we get them. Okay? So first I'm going to change it to a plus problem instead of a minus. So chunka chunka. And then combine your like terms. Both of those are positives. So 9.9. And they are both positive. So the answer is positive. Okay? Remember on these we want to go ahead and rewrite them. Make them look like fractions. We're going to chunka dunka that one. Okay? Then we're going to combine our terms on the top, and then the bottom is just a label because you're adding. So that is -8 over 10, and we do have to simplify that. So -4 over 5. All right, next one, -2 over 3 minus a -4 over 5. Chunka chunka. Okay, we do not have a common denominator. So we need one. What is the common denominator between these two?
15.
15. So I can multiply this by 5 over 5 to get 15, and I can multiply this by 3 over 3 to get to 15. Okay, so that first one turns into a 10 over 15 added to 12 over 15. Now that we've got a common denominator, that stays the same when we're adding or subtracting. Top becomes a 2. Big minus little, take the sign of the big. Okay, and you can't simplify that. Last one, chunka. 10.9. And they're both positive, so the answer is positive. Okay, this is what I mentioned last class, this part, the multi-terms. We want to always try to turn them into a positive clump and a negative clump. Okay? I do not recommend going from here to here to here to here. I would rather you take all the negatives and put it in a pile and all the positives and put it in a pile. Then it's just big minus little. Okay? So first we want to change them all to negatives and positives with chunka. Okay, so we can combine the negatives with the negatives. So right here we got negative 14 and negative 8. And we can combine our positives with our positives. Positive 10 and positive 6. Okay, so that is negative 22 plus 16. Now at this point we can do big minus little. Okay, what is that answer? Negative 6. Okay, just as a reminder, I use the term like terms when we're dealing with this stuff too. So you'll hear it a lot more with other teachers with X's and Y's and all that stuff. And I'll use it that way too, but I start here because these are also like. Okay? So let's try to get everything to plus signs. So chunka. And we can't combine that negative 5.6 with anything. And we're going to combine our positives. So that is 11.9. So now we can subtract and take the bigger sign. So the answer is positive, but what is the answer? What is it? 6.3. Okay, go ahead and do that last one. Chunka. So you can combine those negatives at the beginning, and you can combine those positives at the end, and then subtract negative 6. Did I get that right? Okay. Okay, up next, order of operations. I will shy away from this a little bit as we get better at this stuff, but right now, let's change every subtraction sign, not every negative, every subtraction sign into a positive, or into a plus. So chunka, and chunka. Okay, so those negatives are okay. It's the subtractions we want to get rid of right now. Next, we start on the furthest inside, because order of operations tells us to do parentheses first, and that's why they put the parentheses on the furthest inside grouping symbol. So we're going to combine those, and then go further out, and then go further out. So that's negative 7, and then that's going to be a plus a negative 2 inside this, and then negative 3 plus that. So negative 9, negative 3. So your answer for this is a negative 12. Okay, these are grouping symbols, but they are absolute value lines. So you do have to do them first, but you have to solve them first. So that's a positive 13. It's a minus 3, but we're going to chunka, making that a negative. This is a negative, so chunka. We have plus 2 plus 7 is 9. Combine your positives and then do big minus little. So 13 plus 9 is 22, plus negative 3 is a positive 19. Okay, we're almost done. This one goes really fast because you already know a lot of this stuff. Okay, this is exactly what we talked about last class. Do you remember the two things that make you put it in parentheses? Do you remember when I told you to put it in parentheses? Yes.
If it's next to something and if it's negative.
Good. So if it's next to something or if it's negative. So this 2 doesn't have to be put in parentheses because it's alone and it's positive. But this has to be put in parentheses because it's negative. Okay? So keep those rules at the front of your mind when you're doing this, because if you don't, it can make the calculator get it wrong. Even if you do this in a calculator, if you don't use the parentheses correctly. Okay? So the first step, I want you to always show the first step. So on a test, if it tells you to do this, I want you to at least show that you plugged it in. So that if you get it wrong, I can say, well, it's because you didn't put it in parentheses. So at least show me this step when you're doing this problem. Okay, and then we chunka 7 over 14, which simplifies to 1 over 2, or 1/2. On the bottom one, that x is alone, so we do not have to put it in parentheses. Minus 3, and that 5 is negative, so we're going to put it in parentheses, and it's next to something. So both ways. Okay? So what do we do now? What's the first thing we do? Yeah.
You change the minus sign to a plus sign and then make the 3 negative.
Good. So if we do that, then now we can see that we're not multiplying a 3 times a negative 5, we're multiplying a negative 3 times a negative 5. So that, a lot of times when it's a minus there, people forget that it's connected to the 3. The symbol before is always connected. Okay? So that's a negative 3 times a negative 5, which is 2 plus 15. So our answer is 17. So those of you that are doing it more in your head might see that if we did leave off the parentheses here, it wouldn't necessarily mess it up yet, but as we get to harder stuff, it will. So make sure you follow those rules. Like if we didn't put parentheses here, that would look like minus 5. And so we just got to make sure you use those parentheses when we need them. All right, last thing. Just something totally out of the blue thrown in here. Complementary and supplementary. We know these words. Have we seen them before? Do we remember them? Okay. How do we remember complementary? Anybody know? How do we remember that means 90? It's just a way. You just got to memorize the word. Is that what you've been told? Okay. So there's a couple ways that I say to remember it. First, I love using first letters, right? I said with the base, it's the big one. And the first day I did a couple of those things too. So with this, if I look at that first letter, it's a C. And the word corner starts with a C. So there is the corner that is 90 degrees. So that's why if you ever tell me that it's cold in my room, I'll tell you to go stand in that corner because it's 90 degrees. Okay? All right. Next, supplementary. Supplementary. That S. Straight line. Straight line. Okay? A supplementary is a straight line. That is the way that I was taught as a kid, those two words. Since then, I've come up with a way that I actually liked a little better. So for complementary, if I take those first two letters, C and O, and I just add one line to this, there's your 90 degrees. Okay? And then with supplementary, if I take, this is a little bit more of a stretch, S and U, if I add 3 lines to this one, is 1, 2, 3. There's your 180. Okay? So 90 and 180. That's how I like to remember it. But I was taught the corner and straight line thing as well. Both of those work. Both of those work as long as we remember what those words mean. Again, I'm not gonna test your knowledge of what those words mean. But if it says these two letters make up a straight line, you need to know that that means these two letters add to 180. Okay? All right. So if we needed to solve for x here, if I needed to solve for x on A, we know that it is complementary, so it equals 90. So we can just do x plus 62. And then how do we get x by itself?
You carry 62 over the equal sign.
Uh-huh.
And you add 2.
Okay, so you can move it across the equal sign, and when we move stuff across the equal sign, we change the sign. So it is a positive 62. So when we move it across, it's a negative 62. Or we can write it below, which is how a lot of times it's written, like this. Minus 62 from both sides. This cancels completely, so x equals, what's 90 minus 62? 28. And then this is a straight line, so we know that it equals 180. So y plus 43. Again, we just undo what's happening to y. Y is adding 43, so we're going to subtract 43. So that's going to be, y equals, what's 80 minus 43? There we go. Okay, that's that first section. I would guess that first section is hardest for most of you around where you are subtracting fractions and you have to do common denominators. The rest of that stuff should be stuff that I'm not telling you to do in your head, but a lot of it you could do in your head if you needed to. Okay? So we got just that slight... Oh, man. I forgot it was Wednesday. I was like, man, we only have 14 minutes left. 55 is when we out. Okay, so about a 4-5 minute break, and then I'll push out the next notes to you. So if you want to, your homework is already posted, I believe. So if you want to open that up, you can. Matrices. The next one's the stuff we haven't seen.
Yeah, and then you just have to remember the 3 sticks on top of one drop. No. Yeah, that's different.
It's not posted?
No.
Dang it. I must have posted it for second period.
Gosh, darn it.
Yeah. Yeah. Yep. Yep, that's exactly what I did.
I don't need judgment. I mean,
I'm just saying, I think it's
Okay, how about now? If you reload, 1.6 should be up. I just did not click a sign. Yes.
Has a bikini bottom.
Can I get a reload?
Whoa.
Reload? Can I get a reload?
Wait, no, I did it. No, I did it. The rock as the mask.
Yeah.
It doesn't have a mask. No, I can make it a mask. I'm gonna make a mask for themselves.
I'm going to give you a number to type. Oh, you're in my science, so we need to add you into that. Okay, we just weren't in this one. Okay. Oh, no, come on. You do not need to show work on anything. I just forgot to take it off today.
No.
I know, I'm sorry. I'm sorry.
So is it just the lines or the
No, he won't come
Oh,
off.
wait, let's wait till the end of class, because the quizzes are longer than about 4 minutes. So at the end of class, we'll get you to retake it. Okay, so let me get you Chelsea. Okay, it should pop up for you. And 8120 is the number. I know, or you don't even have to draw a line. You can just ignore it and it won't count.
1.6.
The box will be red, but it's not going to count. You're wrong. Dang it. I can't believe that. That was like one of my goals is don't leave the show work on.
Yes, but it says chum bucket on it.
I did that when I was born.
What did you think that was?
What?
I thought that was Mario.
Well, no, it plays in Mario.
No, it doesn't.
Yes, it does.
What this?
That's the Wii things.
Yeah, and if you play it on Wii, no, it doesn't.
No, it doesn't.
Yes, it does.
That's the week.
It's not Wii. It's not. Gee, man. You're not weird. I drew Iron Man from the. I just drew random. I just drew
Chelsea,
random
did that
bugs.
work?
That almost looks like a whale with hands.
Okay, let me click add.
Oh yeah. No, but it could be one arm of
Awesome.
Iron Man.
Okay, and then during third period, I'll just make sure that we get you set up as I think next class, I'll have to get you to re-sign up for Apple Classroom. You'll just have to do it all again, because I've got a different computer that I'm gonna use at school, because this is my personal, and they gave me one for school actually, so. Just so you know, so next class, I'm just gonna give you, it's gonna be the same thing, you're gonna get the same number.
Right by your
Okay, right now I'm sharing the notes to you, so sorry if it interrupts what you're looking at, but
Goes through half of the screen.
Comment sign.
Biggie cheese.
Thanks, Dad.
No, I said no. I was
This kid.
Can I have it again?
Yeah.
Yay.
I'll put it right to your iPad. What's your iPad's name?
Michael, insert name here. I tried to make it insert name here, but they wouldn't let me take my first name.
Okay, let's see if I can find it. It's not showing up.
Now I don't. And now I just gotta change my name. No, now it's, he's not a real OG. Really? At least not on my iPad. Might be on my phone. Because it closes out.
Did you put it in iBooks? Is that what you did?
I put it in files.
No. Let's see if it shows up when I'm closer to you. It's not coming up with you. I don't know what's going on. Hold on. Let me reload it.
You might just say Michael.
Yeah,
With these, I just maybe have seen these.
maybe.
I know, for some reason it changes.
These are.
Yeah, I don't know why that is.
So that one's you?
Yeah.
Got it? All right, cool.
I also like these.
But the about on your iPad? Oh man, I've been recording this whole time. That's good. Okay, so this is adding and subtracting matrices. Okay, this does not, it is not as hard as it appears. When you first look at it, there's a bunch of numbers. But really, you're just looking at 2 numbers at a time. Okay? Once you get to multiplying them, which we won't do in this class, it's a little bit more challenging. But really, you're just doing a bunch of small math problems, even though there's a bunch of numbers there. Okay? So here is a little bit of vocab. Okay? It is very hard to do matrix problems if you don't know what these words mean. So first, The Matrix. Has anyone seen the Matrix movie? Long time ago? I just read last night that there is a fourth one in the works right now. I'm like, oh man, I don't know. The third one wasn't very good. Yeah, no. Okay, so, but The Matrix. So the reason that movie's called The Matrix is because there's a bunch of numbers going down the screen, right? This is where it kind of gets its name. Okay? So a matrix, let's call this matrix, we're going to call it matrix A. So A equals, and I'm just going to make up this matrix. There's no reason why I'm picking these numbers, but 1, 5, negative 2, 1, half, 0.3, and 7. Okay, that is a matrix. It's just a bunch of numbers in these brackets organized. Okay? So each of those numbers is called an element. This is the element right here. This is an element. This is an element. So elements are parts of the matrix, or the individual numbers of the matrix. Parts of the matrix, or each individual number. The parts of the matrix. So if I ask you to find the element in the top left corner, if you don't know what element means, that's a little harder to do. Okay? The order of the matrix. Okay? So how about this? If I did this, since you're in a math class, what does that mean? 2 times 3. Okay? If I was in Home Depot, what would that mean?
2 by 3.
2 by 3. Okay? So Home Depot, this is the size of something. It is not a multiplication symbol. That's the exact same thing with a matrix. So if I ask you for the order of it, that's the size of the matrix. Okay? So the size of this matrix is a 2 by a 3. And we always say the rows first. Okay? So there are 2 rows and 3 columns. People get those words confused a lot, so think of another place that you would see rows. If you walk into a movie theater, right, you'd see rows. Which way do the rows go? This way. So if you're counting the rows, they're the ones that go this way. Where would you see columns? Where do you see columns? Buildings, like the White House, right? The columns go up and down. So there are 1, 2, 3 up and down columns. Okay? So you always go rows, then columns. Rows and columns. And if you want, you can think, okay, that's opposite of alphabetical order. If you put rows, then columns, that's not alphabetical order. So it's opposite of the alphabetical order. Okay? But we don't use R and C. We use M and N. So rows is M, and columns is N. Which one of those words has an N in it?
Columns.
Okay, so that's going to be the one that has...
And rows has an upside down.
Sure, yes, great. Because I thought you were going to say columns has an M. Yep, there it is. That's what I thought he was going to say. Okay, yes, that is true. But the only one... so I don't know what else to say. It could be the same thing, L, M, N, so it's the opposite of alphabetical order again. Okay? But rows with M, columns with N. Okay? Last, a square matrix. If you use your knowledge of what we just talked about in the word square, what do you think that means?
2 by 2.
A 2 by 2, or a 3 by 3, right? Or a 4 by 4. So when your rows equal your columns. It's just a special type of matrix. Okay, when your rows equal your columns. So it could be, I heard people going up to 6 by 6, 7 by 7. It could be any of those. I would rather not deal with the 7 by 7 matrix. That's a lot of numbers. Okay, so using matrix notation. Using matrix notation. Again, we talked about the word notation. That means the way that you write something. So we're going to write it in matrix form. Understand what is meant by equal matrices? What does equal mean? The same. Okay, so they might not be the same numbers, but they're equal to each other in value, and we'll explain that too. Matrix notation. This is matrix notation. All I want you to tell me is what is the order of the matrix. What's the order of this matrix? What size is this matrix?
2 by 3.
Good. So there's 2 rows and 3 columns. What about the next one?
3 by 2.
Okay, 3 rows and 2 columns. Okay? Okay, now we're going to talk about reading a matrix. So we still do rows first, then columns. So this number down here, that is not the number 23. Okay, that is the number 2 and then the number 3. Rows and then columns. So this is kind of like Battleship, if you've ever played. You go to row 2, go to column 3, and then you just tell me what number's there. See if you hit. Right? So on matrix A, so this also tells you which one to look at. On matrix A, row 2, column 3. So looking at matrix A, we go to row 2, we go to column 3, -1. -1 would be your answer for that. Okay? Okay? Next one. Row 1, column 2. Again, still on matrix A. What's in row 1, column 2? 2. Okay, another way that people view this, if it's hard for you to see, is you highlight those 2 numbers. So row 1, column 2, and the part where we overlap, that's the number we're talking about. Okay, what about B12? B, row 1, column 2, yes, -2. What about B31?
1.
Row 3, column 1, yes, that is a 1. Okay, what about that number 5 that I wrote in there?
0.5.
Well, there's no.
Oh, wait, no, there's
Does not exist is the correct answer. It does not exist. So that will be like on my math app, it will say answer choice B. It does not exist. And you just click B instead of fill out the box on A. It does not exist. Okay, so don't just assume, oh man, that goes off the thing, maybe I flipped them. No, it is always going to be rows then columns. So if you go to row 2 here and then column 3 here, there's nothing there. So does not exist. All right, up next, equal matrices. That just means that these are equal to each other. That means the stuff in the top left is equal to the stuff in the top left. That means the stuff in the top right is equal to the stuff in the top right. So, can you tell me what x has to be here? 1, because it's the same. Top left has to be top left. What about z? What is z?
Oh.
Sorry, I moved down. I went down. Z is 3. Okay? And then last, y plus 1.
Y 6.
Okay? So, also, if you're doing that in your head, some people actually do think 6, because they're just thinking plus 1 real quick. So really what you're doing is you're writing them equal to each other. That's why I said you're viewing it as a bunch of little problems rather than one big one. Y plus 1 equals 5. And then you can solve it from there. But that's how we got 4. So at the bottom I've got written down right there. A equals B. Those are equal matrices. If and only if that x is the same as 1, that y is the same as 4, and that z is the same as 3. Okay? That is the only time that those can be equal, because everything has to match. Can I move on from that? I don't want to. Okay, let me give you a little more time. think we only have a couple more, right? Yeah. A couple more slides. So that's what this next slide says. It says, when you're dealing with matrices, at least with addition and subtraction, you're always dealing with corresponding, so same spot places. That means if I take this one and I set it on top of that one, whatever stuff lands on each other, those are the corresponding positions. So right there. When you're adding and subtracting, same thing. You are going to add stuff that's in corresponding positions. If I've got a matrix and a matrix with a plus sign between them, I'm adding top left to top left, top right to top right. Okay? If the sum or difference of two matrices of different orders, different sizes, is undefined, you cannot add them because there's not always going to be something in the top right compared to something in the top right. So I could not add these two matrices. Because if I'm looking for something in 1, 3, there's not something in 1, 3 to add that to. So we couldn't add those. Okay? So here are two examples. Okay? So what we're going to do, instead of seeing all these numbers and getting overwhelmed, we're viewing 1 and 1 at a time. So just top left with top left. If I add those two together, what do I get? -2. Top middle to top middle.
8.
Top right, top right.
8.
Bottom left to bottom left. 5, and then -3 and -2. Okay, adding them is pretty easy. Subtracting them is not as easy. That's why we turn it into adding, just like we did last section. So before we even start this, I don't like that minus, so what am I going to do with it? Chunka, right? Okay, but when you chunka this middle part, you're going to have to chunka everything in the second matrices. So chunka, or chunka.
Wait, -2.
Okay, so yes, I did not change the 0 because there's not an opposite of 0, right? Okay, so now that it's to a plus, this is as easy as the one above it. -6 added with 5, -1, 7 added to -6 is 1, 2 added to 0, 2, and -3 added to 4. So there are your answers. Okay, matrices do get harder, not as much in this class though. Okay? So this is what we got for matrices. As long as you view them as a bunch of separate problems, it's not that hard. Yes? Yes, we get out at 55 on Wednesday. Yeah? No, you're good. You scared me a little bit too. Okay, so that's the end of it. You've got 20 minutes exactly to get this stuff done. Okay? There were a couple parents last night when I was talking. They were a little concerned with doing work in your head because it's online. So let's make sure you're working the problems out and not guessing your way to the answer, okay? It's not going to help you. If you're not using it correctly, then I might take away that many attempts. Let's use it correctly and learn correctly through it, okay?